presented for us during the last several years during the pandemic, when he was in a previous role. Before the pandemic, you're going to find a lot of great content, a lot of great energy. So I'm thrilled that Nathanael Iversen is here. He's the Chief Evangelist at Zentira. The session is going to focus on strategies to control breach spread and limit data loss. As I mentioned, he's the Chief Evangelist for Zentira. He's also worked for Illumio and other positions in systems engineering, product management, technical marketing. He began his career designing and implementing large-scale data centers for the U.S. Air Force. Please help me extend a very warm welcome to Nathanael Iversen.
Thank you. It is always good to be at a Dan Horwatch event, is it not? Like, he's a wonderful guy, and you all know him, and he knows you, and it's a delightful thing. It's something very special to the Chicago area for those of us that travel around. Well, I get the unique privilege of talking to you mid-afternoon after lunch. Oh boy. Well, as I thought about it, I thought, okay, how can I be of value to this group of IT security professionals? And I made up in my mind that if you were going to give, some of your time to me, and that you would give a day to this, that probably one of the biggest things you'd hope for is to hear something that you hadn't heard before, something that would be fresh. And even better, if it could be actionable. That is, you could actually take something away that could change the way you do things, and that would be worth investing a day. So I make up in my head, but that's one of the reasons that you're here, and I'm going to deliver on that for you, I promise. And the reason is because I would guess that if I just raised my hand and said, how many people have heard me talk about anything about Chambers or about this company called Zentira, would anybody raise their hand? No one would raise their hand. So I feel like I'm in a great position to make good on that promise and tell you something that you haven't exactly heard and help you to think about securing your most important things in a unique and interesting way. So I'm going to do it by asking a question that's a very obvious question, but I actually want you to think about it for a second. And that's this. If heaven forbid somebody was in your environment, what would they go after? Or turn it around, what's the thing you would least like them to get to? And you'll each have that in your mind. As if you'll have that for me as you go through it, I'm not going to ask you to tell me, but if you'll think about the world through that lens, it's interesting because a breach, unfortunately, is the thing that happens after someone's passed your stack. They're past your XDR, your EDR, your IDS, your IPS, your antivirus. I'm pretty tall. The list of things is this long that you have loaded on your machines. The breach is the thing that happens after that. And so if somebody is breached, where are they going? And the second question is, could they get there? Well, I don't know. Like, you're thinking in your mind, well, I don't know. They could get there if these things were true. They could get there if they started from here. They could get there if. But you can immediately start running that calculus of if somebody was past my stack, how easy or hard would it be for them to move around? And unfortunately, the answer is usually it's not that hard because they already got past 15 things. And so what I'll just make the observation is that I now have a green screen. I touched the HDMI cable. There we go. Is that there are many tools that I'll call manage risk. They help you manage the risk that somebody clicks on a thing. They help you manage the risk that somebody downloads a file. They don't prevent any of these things, of course, but they do help you manage the risk. And so there's a lot of things that will protect around an asset. And I'm not here to disparage any of them. You need them because people are going to click on the links. People are going to do the thing, right? We know that. But I'll just observe that there are technologies that secure things around the asset, but they don't actually do much to protect the asset itself. Like your critical asset, the one that I asked you to think about, those 5 or 10 or 15 servers, or 50 or 300, depending on the size of your organization, how do you protect those things when someone's passed your stack? Well, I'm going to go ahead and suggest that segmentation is the thing that helps you to prevent breach spread. And there's going to be network and security engineers who are like, this guy's not very smart. We've known this for 25 years. That's not really a very genius observation. I didn't pay that much money to come here for that little gem. And you'd be right. I'm not expecting this to be a big revelation. But if you think about it, there's truth in this statement. That if somebody's past your stack, the thing that keeps them from going to the average of 12 to 15 hops, which is what they tell us is the average for somebody to get from a relatively unimportant system to an important system, in 92% of times they don't land directly on an important system. So segmentation is the thing that keeps them there. Okay, after the non-genius observation that that's a truism in our industry, why do we not have better segmentation in 2025? I mean, it's not like there's a shortage of ways to do it. I would suggest that for the people in the room, you probably have all the hardware firewalls that you can get money to buy. And secondly, that you can afford humans to type into. And you have as many firewall rules as those humans can produce over their 10 or 15 years as that you've had those firewalls. Yes? Yes. That is probably true. And why do you not have more firewall rules? Because you can't get more firewalls, or you don't want them, or you can't hire more security engineers because they appear to be valuable. None of you will let go of yours. You're all hoping that the guy next to you isn't hiring because you certainly wouldn't tell him that any of your people were looking, right? And so we have the situation where we might think intellectually we want more of them, but operationally, every executive in the room knows that we don't actually want more firewall rules. Because how long does it take to provision a firewall rule at your shop? Weeks? 6 weeks? 4 weeks? 2 weeks? I mean, I know that your guys can type them quick, but they don't get implemented quick because they'll break stuff. They got to be in perfect order, and they have to be typed perfectly, right? And go into a list of thousands, tens of thousands, or millions. I was at a New York bank one time, and I was talking with their firewall administration team, and this guy was very proud of his firewall implementation, as he should be. It's one of the top 3 banks in the United States. It's impressive as heck. And I said, how many firewall rules do you have? And he puffed up his chest and told me 7 million. And you're all laughing, and that was exactly my internal response. So let me get this straight. You've put 7,000 holes in a wall, and you feel good about the protection it's offering. And he kind of smirked and said, I see your point. And that's the thing, it's easy to get a lot of these rules, but it's pretty hard to manage them. If we were to ask that firewall admin, like, can we cut the rules by 25%? What would happen? The dude would panic, because no one knows. The rules have to be perfect, in perfect order. They've been there for how many years? How do we make changes? That's why it takes 4 to 6 weeks to change firewall rule, isn't it? It's because somebody has to go and unsort all of that complexity long enough to put the new rules in. So we have this thing of like, yes, we would like more segmentation in the world, but it turns out to be operationally expensive. The security team will walk in and always say, yeah, give me another pull on the ratchet wrench. Like, how much segmentation is good? Well, just a little more. Like, I just want to hear the comforting click of the ratchet go tick one more time. And 6 months later, I want to tick it again. Meanwhile, if you own firewall administration, or you know the head of network security who owns firewall administration, every time that handle gives a reassuring tick to the security guy, what does it mean on the firewall side? Pain and suffering. And this is why they resist the attempts for more segmentation, right? This is real. And so there's a number of different approaches. We had firewalls, that whole world, we got hypervisors, and now people can do them virtually, and it didn't solve anything. All it did is just meant that you could have more of them, and now they're in software so they can proliferate even faster and quote for free, but you don't get the provisioning for free, unfortunately. Along come a number of host-based companies. There's people with things like microsegmentation slathered all over their websites. Has anybody heard of a microsegmentation project that took too long? Or that didn't finish? Or that broke something? And that's bad, because aren't we supposed to take the Hippocratic Oath as security practitioners, do no harm? Right? Like at the very least, we're not allowed to take the business down. So we all know of those stories. And there are companies that actually propose, you should boil your ocean. That's what you should do. You should take on every server and every flow in your enterprise all at once. And if you've got 1,000 servers, how many flows do you have? 10 million? A lot. It's pretty easy to drown in that ocean. And so against that backdrop, it's interesting to think about, okay, we know we have a technology that can be the backstop. It can be the thing that stands behind all of the security stack that my team's operating, but it's operationally painful and there's unsolved problems. And so in that space, what I want to do is introduce a couple of key ideas to you and talk about how we can actually put protection around the actual assets themselves without taking anything away from all of the other solutions that you have and that you need. And the thing that I'd like to give you as the idea is this. If you've got important stuff that you don't want people to get into, I think you should put a chamber around it. So I'm going to define a couple of terms for you. What's a chamber? Well, a chamber is just a virtual space. It's just like it sounds. It's a perimeter, if you will. Only it's software defined. Well, that's nice because that means that it can flex. Is it tied to your existing subnets, VLANs, and zones? No. That's probably critical because if I come into any of your shops and say, hey, I know we should do this 3 months. Let's go re-VLAN the enterprise. Who's in? Everyone's like, you can go to the door that way, sir. That's not okay, because that's the amount of work that none of us want to do, right? So we can't do that. So these chambers need to be virtual. They need to be independent of the network. They need to be independent of your existing firewall policy. And for sure, what are the things that we need to put in these chambers? Well, if it's your important stuff for your industry, and we have people in this room that have everything from tugboats to financial data and medical data. So if that's the case, what kind of things need to be in these chambers? Well, for sure, compute. For sure, we need to be able to put things like virtual machines, servers, actual Kubernetes containers, things like that. But these are all the compute things, right? So we need to be able to put compute in the chambers. But how many people in the room have things where all you have is an Ethernet cable called OT? How many people are in manufacturing, are in healthcare, are in various forms of civil service, and you have police departments and sensors and fire departments. You have HVAC systems that have automated controls. We may have people that have power or wastewater treatment, and you've got valves or nuclear radiation sensors, as one of our California power plant companies has. And so these things, what's the security stack? You don't have 15 things on those devices. You've got an Ethernet cable. It's like, what's your plan? Like, on Ethernet cable, I guess I need something the Ethernet cable plugs into, because that's what you have to work with. And so we think that these chambers should also include the whole world of devices. And we'll talk about how to make that true, because that's not immediately obvious. Certainly the bulk of the microsegmentation vendors have no answer to those things. They're like, we have software, so we can work on software things. But there are many people in this room that have hardware things. And so how do you take something like this idea of a chamber and apply it? More on that in a second. But if you'll go with me a second on this idea of a chamber, if I spotted you some, and you said, okay, I'm still thinking of the 5 things that you asked me to think about at the beginning of the presentation, the stuff I don't want people in, and I'm like, well, here's 5 chambers you can put around those things. We put the chambers around, what's our first concern? We don't break anything, right? So if we're gonna not break things, the first thing we're gonna need to do is handle all of the core services. I would posit that for most people in the room, the core services are somewhere between 30 and 50 things. If you were to add up whatever mix of Active Directory and DNS, DHCP, network time, blah, 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 like that stuff, there's probably 30 to 50 in your world. And that's gonna cover all of the core services. There'll be logs and alerts, right? Things that have to go out to Splunk and SIM and whatever. There's gonna be, for some of you, you have automated infrastructure where code actually runs part of your world. And so you're actually gonna have things where machines come and go under automation. Chef, Ansible, Puppet, Terraform, fill in the list, right? So we would need to get those things in and out. And what I'll tell you is that from a breach spread perspective, doing a good job with these things yields an uncommon amount of result. And I'll give you a couple of examples just to think through it as an intellectual exercise. Like, what would be the worst typhoid Mary in your environment? What would be the worst thing to get infected? Active Directory? That'd be a bad day, right? How about your DNS server? That'd be a bad day. Why?
It's always DNS.
Why? Well, because these things touch almost every system, right? I mean, the Active Directory certainly touches all the Windows systems, and those of you with a lot of Linux, like, won't bother me when I say DNS, and then it's like, oh, that'd be bad for everything, because like everything needs that. And so if you start to think about, well, wouldn't it be great if the stuff in the chambers only listened to the 2 actual DNS servers that you have? Like, it's not just that you're letting DNS in, it's that you're letting DNS in from the 2 servers that you have, and you won't listen to DNS from anybody else, right? And so there's useful things you can do just in terms of how the core services are groomed into these chambers. But the other thing that we would know, if we just put a chamber around stuff, is that we would immediately realize, well, there's only one purpose for the important stuff in the chambers, and that's for humans to use it, right? Like, that's why we build the applications, it's why we do the things, so we need to let them in, and how and on what basis do we let them in? And this is where I'd like to suggest to you that there's 3 primary things that could be used to improve the access control into a trusted chamber. So the first of them is actually the idea of the user. And this isn't complicated. You guys all have Entra ID, you have Active Directory, you have, Okta, you have MFA, you have Duo, whatever the combination of things you have that establish user identity, that's great. We all understand that. What about the idea of the device? In other words, if I'm coming into your environment, would you prefer that I'm on a laptop that IT issued? Would you prefer that it has the right VPN adapters and that they're up? Would you like me to be logged into the domain? Would you like me to have certain antivirus or my CrowdStrike on with certain updates, right? You probably would. And we could call this posture, right? And so that's the idea of a trusted device. If I'm a trusted user and I'm on a trusted device, how many of you already feel better? Like, that's better than just a password, yes? Better than just a password. And the final thing is the client software. In other words, if I'm coming into this chamber and there's important stuff in here, expensive CNC milling machines, things that are controlling ports or movement of cargo inside a warehouse, or there are servers that have financial, human data, medical billing, whatever it is, when I'm coming in here, if it's a web application, what do you expect me to come in using? Here we go again. Oh, I keep touching things, and that's not good. It's a bad touch. Okay. What do we expect me to use if it's a web application? You expect me to use a browser, right? So if I'm actually using a shell and typing commands into your web server, how do you feel about that? Get away from my web server, sir. I don't want you here, right? So it actually does matter. If I'm supposed to be using a thick client, why am I trying to use a web browser? Or something else, right? Like so sometimes the idea of the executable matters. And so if you had a trusted user on a trusted device using the software that you expect, does that raise your confidence level that this human should be interacting with the stuff inside the chamber? It does. It actually makes a meaningful difference. And so what we think is that if you can start to put some of these things around your most important things, you can actually reduce the actual risk inside your environment. And I don't mean manage the risk, I mean actually reduce it, to bring it down. So let's talk through it a little bit. Some of the things that this does, if you were to just put some of your important things in a chamber, as I say, here's a very interesting statistic for you. If all you did was put one of your most important systems in a chamber, didn't do anything else, and the permissions inside the chamber were permit any. In other words, you can't break the application if you tried. Your application people can update it however they want and it will not break. That's not a super tight policy for the security people in the room, but let's go with it for a second. What if all you did was put a chamber around the things and inside it's any? You would eliminate 80 to 90% of the risk of somebody being able to laterally move into that application. That's astonishing. That is, like, doing that, of putting things into a chamber, is something that I'm used to people being able to do on the order of a couple of weeks. I'd say a couple of hours because that's all it takes to do the work, but we all know that in the real world we actually have to get approvals and testing and, you know, wait for an outage or window and, you know, things like this, right? So I'm just gonna say a couple of weeks. Like, that's an outcome that people can get fairly concretely, fairly quickly, to be able to put important things in a chamber, and you eliminate 80 to 90% of the lateral movement risk. Well, that's pretty good. That means that if people are past your security stack, it's very hard to impossible for them to actually find the things and to actually get at them inside of the chamber. The other interesting thing that is parallel to that is this. How many of you have important things that you cannot patch? Everybody's laughing. Why? Because those are the things that you can't patch are the important things. Why? Because Oracle says you can't patch it, because you will break the database. Or, you know, McKesson says you can't do it because you'll break their support agreement, or, you know, whatever it is, right? It's interesting how often that is. But if you have something, let's say we have a server, you know, my phone will be the server, and this thing has 5 vulnerabilities on it. If this thing's sitting in the middle of your data center with 5 vulnerabilities and can talk to 5,000 machines, that's something of a risk. Because there's the 5 ways that someone could get to this, and they could get from this to everywhere in your data center. But what if this thing is actually inside of a chamber? I haven't patched it. It's still got 5 vulnerabilities. But now it can only talk to the 3 other systems inside the chamber and a couple of users. What's actually true about the risk exposure of my compromised phone or my vulnerability phone? It's a lot less, orders of magnitude less, right? And so it can be that the idea of a chamber can also be a compensating control for the inability to patch. Fascinating. So even though I can't patch it, which we all know is the right thing to do, but we all know that we always can't, wouldn't it be interesting if you could just eliminate the risk from not patching? Or reduce it concretely, measurably? That'd be cool. One of the interesting things is you could start to do some pretty interesting things about third-party access. Now, for all the people in the room that actually have OT, you've got devices. How many of you have to let third parties into those devices? Everybody. Like, that's how it goes. You know, Siemens, whoever it is that makes the sensors, that makes the things, they do it. You buy a $15 million Swiss CNC machine. Are your people patching it? Nope, the vendor's gonna do that, aren't they? And so you've got to let people that don't work for you, using equipment that you have no idea where it's from or what it's doing, touch stuff that's actually making you money, keeping people safe, serving your community, you know, doing important things. And so if we think about these access controls on the front end of a chamber, wouldn't it be great if you could let a third party actually come from wherever in the world they are, encrypted tunnel, to a chamber that only has the stuff they're allowed to do in it, and they can't get anywhere else in your environment. They've never had an IP address in your world. They have no routability to anywhere else and no discoverability. That feels a lot better than giving them a VPN connection. I'm hoping. That would be cool. Okay, well, that's useful. How many people have old things that we'll admit to? Most people have some old things. How old? Well, I don't know. You go into the world of OT, and you have a $15 million CNC machine. Anybody got Windows XP running it? Right? Like, this is where those things happen, is sometimes the critical things are also the things that have really old control planes. Those in manufacturing know this as well. Like, there's SCADA systems and other things that they're not fresh, and they don't need to be.
The manufacturer went away.
Yeah. And you still have the stuff because it's still running the line, and the line's making millions of dollars a month. Yeah, it's a thing.
To change it.
Yes, or to change it. And this is true in wastewater treatment, this is true in electrical distribution, this is true in hospitals, it's true even in big giant banks. They have old machines for reasons too. And I'm not just talking about the Fortran ones. So if you have these old things, it's great if you could suddenly put these things inside a chamber, because again, you only have them because they're important. You don't have them because they're old. None of us are running a computer history museum. There's a good one in San Jose if you ever want to go. But that to the side, we have these because they're actually important. And so if you have old, vulnerable things that are important, what should you do? Put them in a chamber. That's what I would do. Okay, well that's pretty wonderful. We talked about the idea of least privilege access controls going into these chambers, and that's kind of interesting if you were to think about these things not as mandates, but as options. So we have a chamber, we'll just pause it with me for a moment, that we can have these chambers for free, you can have them for free. And so you have some chambers, and you have these three controls in addition to regular IP addresses. I would posit that for some of your important servers and services, you don't want any of these three things. You just want the machines to talk to each other directly. You'd like them to do it in a specific way, maybe encrypted, maybe not, but you would actually allow machines to talk directly to machines without worrying about any of these three things. Great, so we need to do that. That's pretty easy, we can do that. But as we get towards your more and more important things, which of these would you use? Which of these would you turn on? If it was, one of the three things that like without it your world ends, or you get a lot of very angry phone calls from whoever you would get those angry phone calls from. Then it might make sense to say, well, yeah, it's a no-brainer to turn on the user control. Like that's easy because we know about that, but I actually would enforce that the device is one that's mine and it would be on my network, or that it's on my VPN. I would feel great in making that assumption about these critical things. And for some things, you might even care about the software. For others, you might not. Is it possible to paint yourself with too much security for the actual risk profile of the thing? Totally. Totally. Like that's real, right? You guys live in the actual risk-adjusted world all the time. So do we think that people use all of these every time? We do not. But we think it's a super useful menu that if you had some chambers, that you could selectively pick which of these things that you want to do. So let's talk a little bit about how you make these chambers actually real, because that would be important. So far we have these semi-magical chambers that actually have the characteristic of being able to do software and hardware things, and yet they're virtual. Well, that's very strange, because my SCADA systems are not virtual. So we need to talk about the mechanisms and how this actually could be implemented in the complicated real-world environment that you have with all of the complexity that you know and I do not. So let's go through it. For some things, the things that you would want to protect are what I would call software. Now I know that your servers actually run on physical hardware, they do in Amazon or whatever else, but at the end of the day, these things are an operating system-based environment, right? If you've got EC2 machines in Amazon, if you've got VMs in your data center, if you've got hardware dedicated, these are things that are running a fairly modern operating system, probably the last dozen years or so if your team's built it anytime recently. And so these kind of things, and all of the things with hinges, where your users are coming from, these are also primarily software environments, and they're a lot easier for all of us, aren't they? Because you can run security stack there. Some people from the vendor community can say, put our agent on there, do this thing. One of the interesting things about this environment, from the perspective of chambering, is that everything you need to make a chamber is already present in modern operating systems. And what I mean by that is there's a perfectly good stateful firewall there. It's the Windows filtering platform if it's Windows. It's IP tables if it's Linux. And you all know this. You don't use them though. Why? The operational cost. It's too high. Like it turns out you already have a firewall on every system, but good Lord, don't make me type the rules into those things. We're dying with what we're using on the edge of the network, right? So, but they are there. And what that means is the capability to put a chamber around an individual server is already built into the operating system of the device if we could solve the control plane issues of getting the right rules there. Is that fair? That's fair. And are all of the encryption libraries that you would need in order to have encrypted communication between users and servers, are those in the operating system? Totally. You can do IPsec, you can do TLS, there's all kinds of things you can do that are built into the operating system. So the primitives that we need are there. Now, if we were to expand that a little and think about the world of OT, for those of you that have things, as I say, with just an Ethernet cable, that's your security stack, have an Ethernet cable, boss. What do? Well, we're going to need something that can take an Ethernet cable. And I'm going to make the suggestion to you that if you need to chamber software, you can use software. If you need to chamber hardware, you should use hardware. Whoa, that's a weird thing to hear a vendor say in 2025, but it makes a lot of sense if you have OT. Because if you have OT, you actually have things with Ethernet ports, and so we think that it'd be good if you had devices with Ethernet ports that could actually sit in front of the OT devices and basically act as the agent for them. In other words, how would you learn about the IP communications of these things? It's easy in a server world. You can just ask the connection table. You want to know what processes are running? Ask the OS, right? It's not hard. But if you got an OT device, who's it talking to? How much data is it sent? Everybody goes, I don't know. So, what if we put a hardware agent with Ethernet ports in front of it? Now all of a sudden we have an enforcement point and we have a visibility and an inspection point that we could have sitting in front of those OT systems. Well, cool. That's great. Now our chambers might need to get out to PaaS and SaaS services. We might need to have similar sorts of things that work inside of Amazon EC2. All of that's great. And ultimately, if we're doing these kind of checks on user devices and things like that, we've got data and it needs to go somewhere. And so we think that to make this happen, you would actually need some kind of orchestration layer, a brain, some place that could make policy help and decisions for you. And by policies, I mean the whole world of policy discovery, policy development, policy testing, policy distribution, policy enforcement. Like if we were going to make chambers, there's some things that we would need to do, and we certainly don't want to do it the way the firewall rules are done. Because if I offer you that, well, no one wants that. That's too much pain. So we won't do that anymore. No firewall rules. The idea is that we tell the orchestrator what we want to be true in the world. What I want to be true in the world is that I have a chamber around my stuff. And what the orchestrator can do is translate that into rules that these devices can enforce. In other words, the rules can be put into the host firewalls. The rules can be put into the hardware that's sitting in front of the OT devices, and what that makes is a chamber. And the beautiful thing about these chambers is they work like this. Everyone in this room has their own version of their complicated world. You have built networks where people come in from far away. Many of you have things in the cloud that are arbitrarily complex. You have your on-prem data center with all of its joys, burdens, and problems. And for some of you, you also have a whole world of OT things, and they're connected however they are. What I'm suggesting is that if you could actually make chambers that didn't rely on the underlying network, but you could group things however you wanted for your most important things, wouldn't that be great to put them in chambers? And if I could then connect those things and check out the device, the user, the application before letting people into the chambers, would that actually reduce the risk in your environment for your most important things? I think it would. Would it be great if you could have this world of complicated OT things? Those OT things always need to talk to the third-party user. We talked about that. So if we could have somebody get all the way to them, that's great. Does OT need to talk to IT? Almost always. Right? Where's the control layer? Where's the reporting layer, the management layer for these sensors, for these systems? It's often in a rack in the data center. And so there's a real need to have things where things may need to be separated out in the world of Ethernet cables, but then they also need to get back into the world of IT. And so we think that it could be very useful if you could actually have users be able to do nothing more than visit a website, and then when they click on something, a TLS tunnel is built for them to go directly to the thing they're supposed to access in a chamber, and nowhere else. That would be neat. What if the same thing could happen if they were going out to hardware in the OT world? That would be pretty neat, and you could actually have the chambers talk to each other as much as you need to. We think that what this would do is it would allow you to create something we call a zero trust fabric. What's that? It's nothing more than just the interconnection of chambers. Every chamber is a trusted zone. What happens if you start linking up trusted zones? You have an entire trusted network, a trusted fabric built on top of your underlying network. What's your underlying network need to do? Deliver packets. What's it built to do? Deliver packets. And what do we want as security practitioners? We want a secure, trusted space for our most important stuff. And I'm proposing to you that a network of these chambers is exactly the thing that would do that, and that if you were to deploy these chambers in your environment, you would tend to see these three things occur. The first is that you would put better protection around your most critical things. The actual risk would go down. The risk of me touching this cable is very high. But you would see the actual risk go down because the number of exposed ports would plummet. The number of ways that people could get into your most important things would decrease. You would be able to better secure users and device access. Why? You got these three controls. You can check the user, you can check the device posture, and you can actually check the application they're using to come into your chambers. And all of this works to reduce the attack surface, particularly on the things that are the hardest. Those legacy operating systems back to XP. The OT things where all you have is an Ethernet cable. And so what I'll suggest to you is that it is possible to actually have chambers for your most important stuff. The stuff that gives you grief. And it's a great way to deal with the fact that there's risk you can manage, but the risk you eliminate, you don't have to manage. And so at Centera, we think that we're in the risk elimination business. If that's interesting, we'll be here all day. We'll be at the table in the back, and we'd love to talk to you. Thank you so much.